Hi friends, how are you? I am Engineer Er Mohd Suleman. I hope you are all fine. Today we will design a doubly reinforced beam. In the previous video, we have to design a singly reinforced beam. Guys, we are creating a series. In this series, we will design every kind of beam like as simply supported beam, cantilever beam, overhanging beam, fixed beam, continuous beam, and prop cantilever beam. Hello friends. Today we are going to design a doubly reinforced beam. So there is a problem. Design the ultimate moment capacity of a rectangular beam having a width of 280 mm and overall depth 550 mm. The tension and compression reinforcements are 2450 mm square and 400 mm square respectively, provided at an effective cover of 50 mm. Use M30 and FE 500 materials. Use M30 and FE 500 materials. Design the beam. So here we will calculate the every value of this problem. First of all, we will write down the given data. Here, design the ultimate moment capacity of rectangular beam having a width of 280 mm. V is equals to 280 mm. Total depth is equals to 550 mm. D dash is equals to 50 mm. So here the tension and compression reinforcement are 2450 mm square. So AST is equals to 2450 mm square. Compression 400 mm square. So here is the AST, T for tension, ASC, C for compression, mm square. Sorry. Use M30 and FE 500 materials. M30, FCK is equals to 30 Newton per mm square. Fy is equals to 500 Newton per mm square. So first of all, we will calculate the value of effective depth. So what is the formula of effective depth? D is equals to total depth minus effective cover, E dash. So here D is equals to 550 minus 50 is equals to Oh, sorry, 500. So here D is equals to 500. After that, we will go for to calculate area of the tensile reinforcement. So here we will go for page number 96. So I am writing here from page number 96. AST2 is equals to ASC FSC divided by 0.87 FY. 400 into 412 0.87 into 500. After calculation, we will get the value of 378.85. So here we have got the value of AST2, 8.85. We have the formula of area of the tensile reinforcement, that is AST is equals to AST1 plus AST2. AST1 is equals to minus 378.85 is equals to 2071.15. Okay. After getting the value area of tensile reinforcement, we will calculate the maximum depth of neutral axis. So here I am writing maximum depth of neutral axis. Neutral axis. So here we will go for page number 70 of IS code 456/2000. Page number 70. XU max divided by D effective depth is equals to 0.46. This value we have got from page number 70 for FE 500. XU max is equals to 0.46 into 500 into D 500, 230 mm. After getting this value, we will go for depth of neutral axis. So what is the formula of depth of neutral axis? So here XU is equals to 0.87 Fy divided by 0.36 FCK B. This is for singly reinforced beam. Divided by 280. is equals to 298 mm. XU is equals to 298 mm. And here XU max is equals to 230 mm. So here XU greater than XU max. So this section over reinforced. Section over reinforced. This section will be over reinforced. After getting this value, we will calculate ultimate moment. From page number 96. So here we will get the formula. Mu is equals to 0.36 XU max divided by D 1 minus 0.42 XU max divided by D BD square plus FSC ASC D minus D dash. So here 0.36 into 230 divided by 500, 1 minus 0.42 into 230 divided by 500 into 280 into 500 square into 30. Oh, sorry. Here FCK is missing. Because FCK is 30. We are getting the value of M30. Okay. Plus what is FSC? FSC is equals to 412 into 400 bracket 500 minus 50. After calculation, we will get the value of Mu, ultimate moment, 354.73 into 10 to the power 6 Newton mm. In kilonewton, Mu is equals to 354.73 kilonewton meter. This value is kilonewton meter. Okay. Thanks for watching this video.